So we've learned what time is in a definitional sort of standpoint. So how do we really think about defining the time of the motion? So we're going to do a couple examples, but defining the time of the motion. So imagine a basketball player shoots a ball at 30-degree angle towards the basket 15 meters away. The basket is 5 meters above the height of the shot ball. If the basketball player makes it in the basket, how fast did he shoot the ball? So this could be a very important question. If you're analyzing your player's ability to shoot the basketball, we need to be able to say, hey, you need to shoot it at least this fast or it's not making it to the basket. It's a very real application, a little bit of for all you basketball players out there or other players out there. How do we define what we care about? I mean, there's lots we care about in basketball, but how do we define what we care about for this motion? So part of our process is going to be defining that motion. So for our basketball problem, and you can reread it in your notes for this video. For our basketball problem, what begins what I start caring about? What is the initial start that I'm going to care about? And what ends it? You can call it initial, final. You can call it beginning, end, start, end. I don't care. But we want to make sure we know what we care about. So lots of motion. The guy's pushing his arms up. But what starts what we care about that's going to define how fast it has to go? It's really when that ball leaves his hand. So the initial, what begins time point 0, is going to be when the ball leaves the basketball player's hands. Not while it's in his hands, not while he's dribbling, but when he actually leaves his hands is when I start caring what the motion looks like. So what ends that motion? Well, I want to know I'm getting into that basket. After it goes in the basket, I don't really care. So it ends when it hits the basket. And this will really define the whole parameters of my problem when I'm actually going to solve it. It'll tell me where the ball's located in space at the beginning and the end. It'll tell me how fast the ball's going at the beginning and the end. What's it doing? Is it moving? Is it getting faster or slower during that time that I care about? So we will be very explicit about defining these times to help guide us through the problem-solving process. Okay, so let's try another one. So let's say you're driving down the road when a light 35 meters ahead turns red. After a reaction time of half a second, you apply the brakes, coming to a stop as you reach the intersection. If you're going 30 meters per second when you apply the brakes, and it took you 4 seconds to stop, what was your acceleration? How is your car working in terms of its acceleration? All right, so again, you can sort of think about, what do I care about this problem? And now there's a lot more information here. We're reacting, we see the light. Does that start when I care? When do I really care if I'm interested in that slowing down period? All right, so again, you can reference the notes associated with the video in terms of the problem. But what starts it and what ends it? Well, I'm interested in that slowing down period because I'm interested in the slowing down. So what's going to start it is when I start slowing down. Is that when I see the light? Is it when I apply the brakes? It's when I apply the brakes. So I begin my motion when I apply the brakes. The reaction time information is not useful for me for this problem. I care when I apply the brakes. When does the motion end? Well, I'm done with the acceleration phase, which is what I care about, when I stop. So the motion ends when I come to a stop. So now defining the time of the motion is actually helping us pull out what's not important. Ignore what's not important. I don't care about that reaction time part because that's not the motion I care about. So I'm not going to worry about that information in the problem, and I can get it out of my mind. I can avoid it. Get rid of the distractors. All right, so we'll get lots of practice of that as we problem solve. That's our idea of just defining those times. Good job.